Hi students, in today's lecture video, we'll discuss about the topic called graph coloring and chromatic number decision problem under the course design and analysis of algorithm. Myself, Sasireka, assistant professor from the Computer Science and Business System Department from RMD Engineering College. What is a graph coloring algorithm? Okay. So in the previous lecture video, we have discussed about what are the NP problems, what are the P-class problems, what are the different types of problems are there. Okay. So now in today's lecture video, we'll see about the graph coloring problem. This is one of the example of the NP complete problem, right? So what is the NP complete problem? This is an intersection between the NP and the NP art problem, right? So until now, we don't have any efficient algorithm for coloring a graph. Okay. So what is actually a graph coloring problem is like this is a process of assigning colors to the vertices of a graph. We know what are the graph contains. Graph contains some vertices and we have some edges which connecting with the vertices, right? So we have a graph. So we have to color those vertices. But what is the condition for coloring those vertices is the graph must not contain any edge whose end vertices are colored by the same color. Okay, we have to careful in order to provide the color. So no two adjacent vertices should have the same color. So this is one condition we have to follow. Okay. And one more thing is we have to use minimum number of colors. So that is a challenge. Okay, based on your number of vertices, so you have to choose minimum number of colors in order to color your graph. Okay, so that is one of the tasks. There are two conditions. One is you have to careful with any adjacency matrix should not have the same color. And secondly, you have to worry about, you have to concentrate on the minimum number of colors which is used to color your graph. Okay. And whenever you perfectly colored your graph, that type of graph we are calling it as the properly colored graph. Okay. And this graph coloring problem is also called as vertex coloring problem. Like then how many number of colors? Like we have to find out the chromatic number. How many number of colors you are using for coloring your vertices in order to satisfy those conditions also. That is that we are calling it as chromatic number. Example of graph coloring, you can see in graph, this graph is having 5 colors. Okay, this is not at all an efficient algorithm. Okay, since what is our problem is we have to concentrate on no two adjacent should have the same color and also the graph should have minimum color. For 5 vertices, the graph has been used 5 colors. Okay, so each and every vertices is having having a different color. So this is not optimization solution for this graph coloring problem. Let me see how we have to color those graphs. So what are the various applications of this graph coloring? If you talk about, we have discussed about the assignment problem and map coloring, scheduling the task, Sudoku problem, in case of preparing the timetable, conflict resolution. So these are the real-time applications of the graph coloring problems. So we'll see what is the algorithm of this graph coloring. So we use greedy algorithm. So always greedy will always find out the local optimum solution, right? So in order to reach the best optimal solution. Okay. So we'll see the first step is we have to color first vertex with the first color. Let me choose any color and we start with the first vertex with the first color. Now what is the second step is we have to consider the remaining vertices one by one and do the following. Like if you pick the currently you pick the vertex with the lowest numbered color if it has not been used to color any of its adjacent vertices. Okay. And if it has been used, then choose the next least numbered color. If all the previously colored have been used, then assign a new color to the currently picked vertex. So this is the steps we have to follow. What is the drawback of this greedy algorithm is the above algorithm does not always use minimum number of colors. See, based on your in the previous case we have seen on graph color, right? So 5 vertices are there. Each and every vertice is having a single color. Okay, that is not an efficient algorithm, right? So we have to concentrate on minimum number of colors. Okay. What is this chromatic number decision problem? So whenever you are finding out the graph coloring, you got a properly colored graph. So we have to calculate the minimum number of colors which is being required. Okay, so that minimum number we are calling it as the chromatic number. Okay, what are the minimum number of colors which is required to color any graph such that no two adjacent vertices of it or assigned as the same color. So here you can see the previously we seen a graph, the same graph, but there it was 5 colors has been used for coloring those vertices. Okay, but this chromatic number now the colors which is used for this graph is only 3 colors. Okay, but this 3 colors also satisfy the conditions. What are the 2 conditions? You can check the no two adjacent vertices are colored with the same color, right? So it is clearly showing that no two adjacent vertices are not use the same color. Okay, and therefore chromatic number of this graph is 3. So since they have used only 3 colors, the chromatic number of this graph is 3, and we cannot properly color this graph with less than 3. Since this is the minimum number of chromatic number, we can use it for this particular graph. Okay, so based on that, you can provide a solution with the minimum color and also satisfy the adjacency vertices. Okay, no two adjacency vertices should have the same color. And what are the different types of chromatic number of graphs are there? Cycle graph. You take a cycle graph that it contains some end edges and also some end vertices which form a cycle of length n. Okay, and there can be only 2 or 3 number of degrees of all vertices in the cycle graph. Moving on to the planar graph. Okay, so planar graph, if it is drawn in a plane, the edge of the planar graph must not cross each other. Okay, so for this from planar graph, the chromatic number must be less than or equal to 4. Okay, and complete graph, like every vertex in a complete graph is connected with every other vertex. Okay, so in this graph, every vertex should be colored with a different color. Okay, so that means in the complete graph, 2 vertices do not contain the same color. So always this chromatic number for this graph, complete graph will be equal to number of vertices in the graph. And lastly, we have bipartite graph. It contains some 2 set of vertices. Different vertices are there like A and B. And we have to join the vertices set from A to B. That means the edge cannot join the vertices with the set. So bipartite, the chromatic number of bipartite is always equal to 2. Okay. And the final type, which is called tree, this is that is no circuit in the graph. So chromatic number will be equal to 2, no matter how many vertices are there in the tree. Every bipartite graph is also a tree. The chromatic number for the T is always equal to number 2. Okay. This is all about the graph coloring and decision problem. Thank you.